Welcome to our channel Learning Math. In this video, we're going to solve an extra problem in exponential functions for grade 12. Let's start together. Here we have the function f of x equals x plus 2 minus 4 exponential x over exponential x minus e squared, defined on the interval I, which is 2 opened plus infinity. Let C be the representative curve of this function in the orthonormal system OIJ. In part 1, show that x equals 2 is an asymptote to C. In this case, we need to calculate limit for f of x as x tends to 2. If you know something, let's first calculate limit as x tends to for 4 exponential x over exponential x minus e squared. If you note here, we can replace x by 2. It gives us 4e squared over e squared minus e squared. So it's 4e squared over 0. It gives us plus infinity. Now what should be the limit for f of x in this case as x tends to 2? Here we can also replace x by 2. So it will give us 2 plus 2 minus the limit here which we have just calculated, which is plus infinity. So it gives us 4 minus times plus minus infinity, so it's minus infinity. But here limit as x tends to 2 for f of x is minus infinity. Therefore we can say that x equals 2 is a vertical asymptote to the representative curve C of f. Now calculate limit as x tends to plus infinity for f of x. Let's calculate it together. By the same method, let's calculate first limit as x tends to plus infinity for 4 exponential x over ex minus e squared. If you note here, if we replace x by infinity, limit as x tends to infinity for exponential x gives us infinity. So it will be infinity over infinity, which is indeterminate. In this case, since we have a fraction, we can apply L'Hopital rule. So it will give us limit as x tends to plus infinity, So by applying L'Hopital rule, we can say it's equal to limit as x tends to plus infinity for the derivative of the numerator, which gives us 4 exponential x, the same, over the derivative of the denominator. The derivative of ex is exponential x also, while the derivative of the constant here is 0. So it's the limit, as x tends to plus infinity for 4 exponential x over exponential x. Note that here we can also simplify exponential x by exponential x. It gives us 4. So limit as x tends to plus infinity for 4 is equal to 4. Now let's calculate limit as x tends to plus infinity for f of x. If you note here, it will be infinity plus 2 minus 4. So here it will be equal also to plus infinity. Now show that the straight line D, which has the equation y equals x minus 2, is an oblique asymptote to the curve C. In this case, we need to calculate limit as x tends to plus infinity for f of x minus y, which gives us the equation of the straight line D. Well, we replace f of x by its value in the given, minus y, the equation of the straight line is y equals x minus 2, so we replace y by x minus 2, and now we can solve. Here, sure, we multiply by minus, it gives us minus x plus 2. Now, before calculating the limit, note that we can simplify x minus x. Also here, 2 plus 2 is 4. So it's equal limit as x tends to plus infinity for 4 minus 4 exponential x over exponential x minus e squared. Well, we have just calculated limit as x tends to plus infinity for 4 exponential x over exponential x minus e squared. It gave us 4. So it's equal 4 minus 4 equal 0. Therefore, in this case, we can say that the straight line D of equation y equals x minus 2 is an oblique asymptote to the curve C, the representative curve of f. Now study the relative positions of C and D. Note that if we calculate f of x minus y, we have just calculated it in the previous part. It gave us 4 minus 4 exponential x over exponential x minus e squared. Now let's study its sign if it's positive or negative. First of all, we can transform into the same denominator. 4 is 4 over 1. It gives us 4 exponential x minus 4 e squared minus 4 exponential x over exponential x minus e squared. Here we can simplify 4 exponential x by 4 exponential x. So it gives us minus 4 e squared over exponential x minus e squared. Now let's study its sign together. So we have calculated that f of x minus y is equal minus 4 e squared, which is negative, over exponential x minus e squared, which is positive for every x greater than 2. On the given interval, it's from 2 till plus infinity. So here negative over positive, minus over plus, it gives us minus. We can deduce in this case that f of x minus y is negative. Therefore, the curve C is below the straight line D. Now show that f prime of x is positive for every x belongs to I. So in this case, we need to calculate f prime of x, the derivative of f, and then set up the table of variations to f. Now let's start by the derivative. First of all, we have f of x. We can write it from the given. Note that here we have it in the form of u over v. So u over v prime, we should keep it in mind, is equal to u prime v minus v prime u over v squared. Now here the derivative of x plus 2 is 1. So f prime of x is equal to 1 minus the derivative of the numerator, which is 4 exponential x, times the denominator, which is exponential x minus e squared, minus v prime, which is the derivative of the denominator, which is exponential x, into u, which is 4 exponential x, over v squared, so it's exponential x minus e squared all squared. Now we can just expand them, so it's equal here 1 minus 4 exponential x times exponential x, it gives us exponential 2x. Sure, x plus x is 2x. Here also minus 4 exponential x times exponential 2, so it's exponential x plus 2 by applying the properties of exponential functions. Also here we can multiply exponential x times exponential x, it gives us exponential 2x, so it's 4 exponential 2x. Note that here we can also simplify, we get it minus 4 exponential x plus 2 over exponential x minus e squared all squared. Now if you note, we can multiply minus times minus, it gives us plus. Therefore f of x is equal to 1 plus 4 exponential x plus 2 over exponential x minus e squared all squared. The numerator is positive and the denominator is squared. It's also positive for every x belongs to I. If we add to it 1, sure it will remain positive. Therefore f prime of x is positive for every x belongs to I. Now also set up the table of variations and verify that the equation f of x equals 0 admits a unique solution on I. So, the unique solution alpha, on I, such that alpha is between 3 and 3.5. First of all, let's set up the table of variation. We have x, which varies from 2 till plus infinity. We have f prime of x and f of x. Sure, here it's from 2 open till plus infinity, so it will be not defined on 2. Note that f prime of x is positive, then f of x will be strictly increasing. Well, it increases from limit for f of x as x tends to 2, which is minus infinity, till limit at plus infinity for f of x, which is plus infinity. Well, note that f is continuous and strictly increasing on the interval 2 open plus infinity, so it will be in particular increasing, continuous and strictly increasing on the interval 3.5. Well, something else. We have f of 3 is approximately minus 1.33, which is negative. And if we also calculate f of 3.5, it gives us approximately 0.35, which is positive. Or we can calculate the product of f of 3 and f of 3.5. It will also give us a negative answer. Therefore, we can say by intermediate value theorem that f admits a unique solution, a unique root alpha, such that 3 is less than alpha less than 3.5. Now let's draw the curve of f. If you note something, First of all, we should draw the asymptotes. Here, the first, the vertical asymptote, which is x equal to, the second, which is the oblique asymptote d, having the equation y equals x minus 2. Note that f is continuous and strictly increasing. Here it's dotted. We will draw it as you see in this figure. Well, it's strictly increasing. It also intersects the axis x prime or x at the root alpha here. So we have f of alpha is 0. Something else. Now designate by D the region limited by the curve C, the straight line D, and the lines of equations x equals 4 and x equal 5. First, we need to calculate integral for exponential x over exponential x minus e squared from 4 to 5, integral dx. Let's calculate it first, and then we're going to solve the next part. If you note something here, if we take q equals exponential x minus e squared, in this case, let's calculate the derivative. Then du will be exponential x minus 0, which is the derivative of the constant e squared, so it's exponential x dx. Well, something else. If you note here, exponential x dx is exactly du, as if we are calculating integral du over u. Something else, here, x tends to 4, or x, we can say for x equal 4, we have u is exponential x minus e squared, so it's exponential 4 minus e squared. Also for x equal 5, we have u will be exponential 5 minus e squared. So we can replace this integral by integral du over u, but we replace the values of u instead the values of x. So it's from exponential 4 minus e squared into exponential 5 minus e squared. Now integral du over u, sure it's ln absolute u. It varies from exponential 4 minus e squared to exponential 5 minus e squared, so we can replace u by these values. It will be then ln exponential 5 minus e squared, here the greater value, minus ln e squared minus, exponential 4 minus e squared, the higher value here, the top one, minus the value for the lower one. We replace u by these values. Well, if we calculate it, it will be approximately 1.094. Now finally, deduce the area A of the limited region D. First, let's see this region. It's limited between the curve C, the straight line D, which is the asymptote to C. Also, it's limited between the straight lines having equations x equal 4 and x equal 5. If you note something here, we have the curve C, we have proved it below D, below the straight line D. Now we can say that the area of this limited region is equal to integral from 4 to 5 for y minus f of x dx. We have calculated previously y minus f of x, which gave us 4 exponential x over exponential x minus e squared. Using integral, we can write the constant 4 outside. So it will be 4 times integral from 4 to 5 for exponential x over exponential x minus e squared dx. Note that we have just calculated this integral. We need just to multiply it by 4. So it's approximately 4 times 1.094. It gives us approximately 4.377. Sure, we're going to solve much more problems. Thank you for watching. If you enjoyed this video, please like, share, and subscribe for the continuity of our channel to support you by more and more information. Thank you for watching.